Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound shown has two stereocenters. Reading the wedge dash notation, it is an amino alcohol. One carbon bears pH, NH2, and H. The adjacent carbon bears of CH3, pH, and H. The arrangement shown is 1R, 2S, or 1S, 2R, specifically the trio or erythro isomer consistent with the drawn configuration. The compound is 2-amino, 1,2-diphenyl, 1-propanol, with the amino group on C2 and OH on C1 or vice versa, i.e., it is a beta-amino alcohol. Moving on to the next step. HNO2 converts primary amines to diazonium ions, ARNH to ARN2+, or aliphatic RNH to RN2+, which rapidly loses N2. For an aliphatic beta-amino alcohol, the reaction with HNO2 proceeds via a diazonium intermediate that undergoes neighboring group participation by the adjacent OH. This is a semipinacol type or Whitmore rearrangement. Moving on to the next step. The NH2 is converted to N2+, diazonium. The adjacent C of carbon's substituents can migrate to the carbocation center with departure of N2. Specifically, the phenyl group, or hydride, on the carbon bearing OH migrates to the carbon that lost N2 with inversion at that carbon. This is a 1,2-phenyl shift or 1,2-hydride shift. Given the stereochemistry of the starting beta-amino alcohol, the migration occurs with anti-periplanar geometry. The migrating group and the leaving N2 must be anti. The result is an aldehyde or ketone product. And for the final step, the migration of pH from the carbon-bearing OH to the diazonium carbon gives an oxocarbenium that collapses to an aldehyde. The product is PHCH, CH3, CHO rearranged, or more precisely PHCOCH, CH3, PH. Actually, starting from pH, NH2, H, CC, or CH3, pH, H, the NH2 carbon becomes the electrophilic center, pH migrates from the adjacent carbon, bearing OH, CH3, pH, to give pHCO with retention inversion considerations, and the other carbon becomes PHC, is equal to O, with the CH3 and remaining pH. The product is PHC, is equal to O, CH, pH, CH3, i.e., an alpha-phenyl propiophenone derivative, PHCOCH, CH3, pH. Because the 1,2-phenyl shift occurs with inversion at the migrating terminus and the starting material has a defined configuration, the product retains a single stereocenter at the alpha carbon. The reaction is stereospecific, anti-migration, so a single diastereomeric starting material gives a single enantiomeric product, not a racemate, not a mixture of diastereomers. Option A shows PHC is equal to OH, which would be an aldehyde with an extra H on the carbonyl carbon. This represents PHCHO attached to CH, CH3, PH, i.e., the product where H migrates. Option B shows PHC is equal to O, CH, CH3, PH, with defined stereochemistry, wedge dash, representing the product of pH migration giving a single stereoisomeric ketone. Since phenyl migrates preferentially over H, phenyl has better migratory aptitude, and the stereochemistry is defined by the anti-migration from a single starting stereoisomer. Option B, a single stereoisomeric ketone, is the major product. C, racemic would imply loss of stereochemical information, but the anti-migration is stereospecific. D, diastereomers would imply two stereocenters in the product or a mixture, but the product has only one stereocenter and the reaction is stereospecific giving one isomer. Therefore, the correct answer is A. Therefore, the correct answer is option A.